and in this video we are going to learn about set operators in relational algebra. So we already have seen some of the set operators like union, intersection, minus and all. Okay, so we will be looking at each of them separately. So first of all, we are going to learn about union. So union and minus is the basic set operator. Okay, so these are the basic operators, and my intersection is a derived operator. So these are the basic operator. Okay, and intersection is a derived operator. Derived operator. Okay, it is intersection. So it is derived from which operation? Intersection. So it is derived from minus, derived operator from minus. Okay, so to use any of these really basic set operator, there is a rule. To use any of these set operators, therefore we are covering all these operators in a separate group, that is set operators. Okay, so use any of these set operators in any relation like R union S, R intersection S, R minus S. We need to know that relation R and S must be compatible. Relation R and S must be compatible. Okay. Now, what does this compatibility means? So, we can say for union, like if we say for a union operator, which is a set operator, so R and S are union compatible, are union compatible if and only if first number of attributes in R is equal to number of attributes in S. Okay, this is the first rule of compatibility. Number of attributes in R has to be equal to the number of attributes in S. And secondly, uh, or we can say, and domain of ith attribute, domain of ith attribute of R and S must be same, must be same. So if it is something like R and it consists of attribute like AB, and we have S which consists of attribute CD, then domain of A and C and B and D has to be the same, and number of attributes in R and number of attributes in S has to be the same. Okay, so then only we can perform union, intersection or minus over that. Okay, so domain, for example, number of attributes, we can easily identify that there are two attributes in R, so there has to be two attributes in S as well. Okay, but what is this domain? So it's something like if we are taking the projection of SID and S name from student, and this we are making a union with or intersection with or minus with projection of SID and marks from student. So now you see, there are two fields, so number of attributes in both the set are equal, SIDS name, SID marks. However, this has the same domain, but S name has not the same domain as marks. Okay, so this is a different, this is different. So here it is not union compatible, not intersection compatible, and not this minus compatible. Okay, so the domain has to be matched, right? Next thing is whenever we perform a set operator on any two relation, so like if we perform r union s or r intersection s or r minus s, then it always yields into distinct tuple. Okay, this always results into distinct tuples, right? So R union S, R intersection S, or R minus S always result into distinct tuple. For example, if we have a relation R and there is an attribute A and it consists of element like 2, 2, 3, 3, and 4, and then we have another relation S and it consists of attribute A and it has 2, 2, 3, 3, and 5, then if we are performing intersection operator on S, then it will be something like there will be attribute A and whatever is common. So we will learn about how to find it. So 2, 2 is common, right? Then 3, 3 is common. Okay, so out of that, if we are performing intersection, it won't be 2, 2, and 3, 3. It will be 2 and 3. Why it will be 2 and 3? Because this operator always result into distinct tuples. Okay, so let's see what union is. So first of all, union is it retrieves it retrieves records of R or S that is equal to R union S. So we can say that R union S is equivalent to X such that X belongs to R or X belong to S. Okay. So R union S is X such that X belongs to R or X belong to S. Okay. So this is OR condition, right? Either X belongs to R or X belong to S. Similarly, for this we can see examples. For example, there is a relation R and it consists of attributes A, B, C, and for them the values are 2, 4, 5, 3, 4, 6, and 4, 2, 5. Okay, these are the values. And then we have another relation S, and this consists of attributes like DEF. So DEF. So 3, 4, 6, 4, 2, 5, and 4, 2, 6. Now, if we are taking R union S, so this is union, not U. So it will consist of like attributes like A, B, C. Okay. So see, these all together are like having different name, but in reality it will be the having the same name as one attribute. It will be taken as one attribute. So having one domain is essential here. Now it will contain all those attribute present in R and S. So if we see, this is one common attribute 425. Okay, so it won't be repeated. And this is also a common attribute, right? So these two won't be repeated. It will come as a distinct tuple when we are performing union. Okay, so it will come as 245, then 345, 346, then 425, and 426. So altogether, four tuples will be there in the union operation. Okay, so note that R union S, R intersection S, and R minus S always result into distinct tuple. Okay, then we will see something like we have already like we are performing the outer join. So if we have T1 and AB, and similarly if we have T2 and AB, and if we are performing T1 union T2, then it is equivalent, the result is equivalent to T1 outer join with T2. Okay, so this is an important result. So union is equivalent to the outer join. So you can see this also like if we have T1 T2, so T1 is AB and it consists of 2 4 and 2 5, and T2 is also AB. So it consists of 2 4 and 5 5. So if we are trying to perform the outer join. So based on the common attribute, we are going to perform this part, join, outer join. So it will be something, so ab is the common attribute, and this is the common part. Okay, so we are having ab, and then 2 4, and 2 4 will be coming once, and then 2 5 and 5 5. So if we are taking union, it is the same result, right? So this is one important part for union. Next is intersection. Okay, so what's intersection is? So intersection is represented by this sign, and it retrieves records of R and S. Okay, so it retrieves records of R and S. Okay, and it is equivalent to R intersection S. So R intersection S is equivalent to or it covers X such that X belongs to R and X belongs to S as well. So X is a tuple that belongs to R intersection S such that X belongs to R and X belongs to S. Okay, so this is a important point to note here. Now, let's say take if we have already the relation R and S, so R intersection S would be something like written as, so A, B, C, and whatever is the common between them, we write that. Okay, so 2, 4, 5 is not the common. It's 4, 2, 5, and 3, 4, 6. Okay, so 3, 4, 6, and 4, 2, 5. Okay, so these were the common attributes, so we take that. Right now, our intersection S can be also be written as, since intersection is a derived operator, so it can be written as R minus S. So we are subtracting whatever is there in R. I mean, R minus S means subtracting what is not in S. Okay, so R minus S, it's something like you can represent like this. So it is S, this is R. So R minus S would be something what is present in R but it is not in S. So we are subtracting this part from the entire R part. So hence this is R intersection S. Okay, and in terms of the join operation, we can write that T1 intersection T2 is equivalent to T1 natural join with T2, because here we are taking the common attributes between T1 and T2. Okay, so note that T1 T2 should be same, and also number of attributes and same name of attribute. Okay, so number of attributes in T1 and T2 should be same, and domain has to be also the same, so we can write that same name of attributes. Right now, the third one is minus operator. Okay, so this is also one more basic set operator, minus. So if we write R minus S, it means retrieve records of R records of R but not S, okay, so R minus S is equivalent to X such that X belongs to R and X does not belongs to S. Okay, so this is the condition. If we represent it in terms of a join, so it is something like R join with X. Okay, so okay, so here we can't take this part, because this will take all those which are present in R as well. It will also take something which is common in R and S. Okay, so we can't write this like this, but yeah, from this if we are subtracting our common. Okay, so this will give us r minus s, something like that, right? So what we are doing here, that first of all we are taking all the r, or in simply way we can write it like r minus and doing like this, right? This is also the same actually. So yeah, this way we can find out these operations. There is one expression, there is one question based on to that. So let's say if we have a question like r is there and it is having pq. Okay, we'll solve some sort of queries based on a set operator in the upcoming video. And also there's one more topic left, that is the division operator, which is also very important part. Okay, so but before that, let's see one question. So it is r consisting of pq, p1, p2 and p3. So these are the attributes of r, and s has having attribute pq and q1 and q2. So if we write pi, we are taking the projection of p, and here we are taking projection of pq from r, and we are doing natural join with pq and s. So here we are taking p and we are doing this natural join of pqr and pqs. Okay, so yeah, and another one is this pi p, and we are taking this from r, and then we are doing this natural join with pi p of s. Okay, so now we are taking something like pi p and pi pq and r, and we are taking intersection of pi pq and s. Okay, right, and then we are doing something like pi p, and then we are doing here pi pqr minus pi pqr minus pi pqs. So in all these, if you see, all these appear to be similarly equivalent, but there is something that is like equivalent to all of them, right? So here this is just odd one out. Okay, this one is just odd one out. Rest, if you see, these all three things are the equivalent form of each other, right? So this is just odd one out. Remaining this 1, 3 and 4 are equivalent. Okay, so yeah, that's it for this lecture. In the next upcoming video, we are going to see some of the questions on the set operator, and then we will proceed towards division operator, which is also a very important part in relational algebra. Yeah, so that's it for this part. If you do have any comments or questions, please do post in the comment section. I'll be happy to help. Thank you very much.